Hello, everyone. This is Zhuohuang from Indiana University. I'm very excited to present our recent work on speech assessment. The title of our paper is An End-to-End Non-Intrusive Model for Subjective and Objective Real-World Speech Assessment Using a Multi-Task Framework. First, I will give a brief introduction on speech assessment. So we know speech assessment is important for evaluating and improving the performance of many applications, including speech separation systems, voice over internet protocol evaluation, etc. Subjective ratings provide the most reliable and accurate form of assessment, but it is often costly and time-consuming. Therefore, people often use the objective metrics as they're easy to compute and they allow quick assessment of large-scale datasets. And there are two types of objective metrics, including the intrusive ones, which requires a clean reference signal during the assessment, such as PASC and eSTOI. However, in practice, the clean reference is not always available in real-world environments. And the second type is so-called the non-intrusive metric, which does not require a clean reference signal for evaluation. However, it does not always correlate well with the subjective ratings. So recent developments on speech assessment matrix mainly based on data-driven approaches. The models such as QualityNet and NISCA, they have been proposed to estimate some objective scores such as PASC or POQA of the input speech signal, but this is not a direct estimate of subjective ratings. There are some other approaches proposed to predict the mean opinion scores collected from human listeners using simulated datasets. So the dataset itself does not reflect real-world environments. So in this work, the first contribution is that we propose a non-intrusive speech assessment system that estimates not only objective ratings, but also subjective ratings for real-world recorded speech. And secondly, an end-to-end model is developed by encoding the time domain speech with a convolution layer rather than the conventional short-time Fourier transform. And it also enables direct comparisons between real-world and laboratory experiments. Then I'm going to introduce our real-world speech data, basically based on the two datasets that is publicly available, the cosine dataset and voices datasets. So we did an online listening study for subjective ratings, which we use Amazon MTurk, and we posted 700 human intelligence tasks, and each completed by 5 workers. And following the Mushra procedure, and ratings on speech quality were given between 0 to 100. And next, I will introduce our proposed model. Basically, the model consists of 2 types of layers, including the shared encoder layers that is based on 1D convolutional layer to extract the features or conventional short-time Fourier transform, and then followed by 2D convolutional layers and the pyramid bidirectional LSTM layers to capture the shared information. Then we have this task-specific decoding layers that is based on self-attention mechanism. The decoder part focuses on different aspects of the learned latent feature and makes task-specific estimates of different metrics. And in our study, we are predicting the human MOS, the PASC score, eSTOI, and SDR. Finally, the entire model is updated using a weighted loss from the four targets. So then we will discuss the experiment comparison. The models we evaluated, including a multi-task model for objective score estimation, the QualityNet, the NISCA, and a DNN-based model, and the pyramid LSTM-based model. The speech data, all signals are resampled at 16 kilohertz, and audios are truncated to 4 seconds. The 2 datasets are split into training sets, validation set, and testing sets. We used 20 sample kernel size with 10 sample strike for 1D convolution with 257 output channels. For 2D convolutional layers, we use a 3x3 kernel, and the output channel set to 16, 32, 64, and 128, respectively. And we also adopted 3 blocks of pyramid bidirectional LSTM layers with 128, 64, and 32 units in each direction. The model is trained 100 epochs using the Adam optimizer. And this is the result. As we can see in the table, the proposed system achieves better correlation with human ratings on real-world dataset. If you just take a look at the Pearson correlation coefficients on the most target, and also in all other metrics, our proposed system achieves better performance in almost all targets than other methods. And finally, we noticed that within our model, comparing between the 1D convolutional layer and the conventional short-time Fourier transform, the learnable 1D convolutional layer yields better performance, slight improvements for all targets. And this is the correlation between the estimated scores and the ground truths on the cosine and voices datasets. So basically, we can see that our model has most of its estimations fall on the diagonals, which reflects the high correlation results. So in conclusion, we have proposed a novel multi-text data-driven non-intrusive speech assessment model that can analyze the speech quality from both subjective and many objective perspectives. The proposed model achieves higher correlations, lower estimation errors when compared to the other state-of-the-art systems on the evaluated datasets. Also, there is a better encoding capability with a 1D convolutional layer than conventional short-time Fourier transform. And our future work will move on to subjective intelligibility estimation and even test the generalization ability of our model. That's all. Thank you everyone for your attention.